Hey folks, just a quick little video to introduce acceleration. It is technically part of this standard, but we're really going to dig into it in a later standard. So take notes now, and we'll really deal with acceleration in detail for the rest of the unit after 1.1. Okay, so definition of acceleration is really similar to the definition for velocity. So velocity was the rate of change in position. Acceleration, also a vector, and it represents the rate of change in the velocity of an object. Now, this is one of the first concepts that we're learning this year. It's actually one of the hardest to understand what rate of change in velocity means. And so your first major victory in physics will be understanding what acceleration is in every sense. So we'll just start with the basics. Acceleration is a lowercase a. It's a vector. And then because it's the rate of change in velocity, we get change in velocity over time interval. So change in velocity divided by the change in time, or the amount of time. It's velocity divided by time. And so the units for acceleration can be written in one of two ways. The one you'll see me use is meters per second squared. The other one is, sometimes you'll see a book or a website use meters per second per second. This can be a little bit helpful as opposed to meters per second squared, because you can still see the units for velocity. So one way to think of what acceleration is how many meters per second, or by how many meters per second did the velocity change, divided by how long it took that change to happen. Okay. Now, acceleration can happen in one of three ways. And again, acceleration is difficult, so there's some stuff that's not necessarily intuitive. So three possible changes that an object can have that represent acceleration. Speeding up is the first one. And when we say speed up in physics, we mean that the magnitude of the velocity has increased. Now, that's something that your brain is going to need to sit with a little bit. So I'm going to write a couple more things. So when I say speed up, a lot of you are driving now or learning how to drive. So you're going to use the gas pedal to change your velocity and speed up. So you will accelerate when you hit the gas pedal. The increase in the magnitude of the velocity, another way to say that is the velocity gets further from zero, right? The smallest possible magnitude that a vector can have is zero. And so the further away you get from zero, the bigger the magnitude of the velocity. Now, that can be more positive velocities. That can also be more negative velocities. So the greater the positive or negative number you have for your velocity, the faster you are going. So that's one way to accelerate. The second way is to slow down. And so you, as a driver, would use your brake pedal to slow down. And that means that the magnitude of your velocity would decrease. The velocity gets closer to zero. When we learn about motion graphs, this is one of the most confusing things, but it's also one of the most helpful things about a motion graph. So the smaller the speed, the smaller the magnitude of the velocity. And the last one is a change in direction. We don't deal with this one as much in this physics course as you would in like college physics course, but we do deal with it a bit. When you change direction in a car, you use the steering wheel. And so every time you use the steering wheel to change direction, you have caused acceleration. Velocity is a vector. And so if you change the direction of the velocity, then you have actually changed the velocity, and you have caused acceleration. So I'm going to skip the calculations having to do with acceleration until we get to another part of this unit. And so we'll just leave it at this for acceleration. Thanks.